Welcome everybody. We'll start this semester's series of leg seminars with Daiki Kishishita from Hitotsubashi University, who's going to be talking to us about the population dynamics of conspiracy thinking. So, over to you, Daiki.
Thank you so much for having me this opportunity. And my co-author Emre is also joining this seminar, so you can ask him as well. Okay, so let me start with a kind of a broad motivation of this study. So this study is about a conspiracy theories. And as conspiracy theories are unfortunately widespread in the current world, like COVID-19 related conspiracy theories or something like climate change related conspiracy theories, and so on and so on. And of course, they have some negative consequences on society. So in response to that, there are so many empirical papers in political science and social psychology analyzing what is a cause or what is determinant of beliefs in conspiracy theories. And one important consensus in this literature is that people who believe in one particular conspiracy theory, let's say, COVID-19 related conspiracy theories, is also like to believe in other conspiracy theories, even unrelated conspiracy theories, like climate change related conspiracy theories and so on. So this indicates some psychological tendency to prefer conspiracy explanations for social phenomena, and this is called a conspiracy thinking or conspiracy mindset in the literature. And one important fact about this conspiracy thinking, this psychological trait, is that there is a cross-country or cross-group differences in the average level of this conspiracy thinking. So for example, so they conduct a kind of multi-country survey across 19 countries, and they measure each individual's level of conspiracy thinking. And this is 0 to 7. And in Brazil, the average level is 5.27. This is the largest actual average level in these 19 countries. But in the Sweden, this is the lowest level, so 3.79. So there is some cross-country difference. And also there are sometimes even cross-group differences in one specific countries. So for example, some literature shows that that conspiracy thinking is correlated with political ideology. Like conservatives are more likely to have a conspiracy thinking or something. But for this, there are some controversy about it, and I will come back to this point later. But there are some claims that there exist cross group political group differences in the level of conspiracy thinking. And this is important because this indicates that the impact of conspiracy theories could vary across countries and groups or could vary across contexts because of the difference in the level of conspiracy thinking. Right? Then the natural research question is, so what is the cause of such cross-country or cross-group differences? So this is obviously important question, but surprisingly, the existing theoretical studies cannot answer this question. The reason is not because that the existing studies focus on rational agent. Actually, recently there are so many papers that try to incorporate some psychological biases of voters into the model of political economy. So this is not the reason. The reason is that even such papers assume the exogenous distribution of psychological biases. Like, for example, let's assume that a half of voters conduct motivated reasoning and the other half of voters are Bayesian rational. What is its impact on electoral competition or something like that? So that is what the existing theoretical studies analyze. And then by definition, because distribution of psychological bias is exogenously given, we cannot answer this question. So we want to endogenize the distribution of psychological biases. So that is our contribution. And for this, we're gonna focus on highlight the dynamic interaction between conspiracy thinking and the quality of information environment. So let me explain this. Okay. So first of all, we're going to show that whether people have a conspiracy thinking or not should affect what information experts provide. So for example, let's assume that you are an expert about climate change, okay? But a lot of citizens, the receiver of your information, have conspiracy thinking, okay? And if you say something truth, or I mean that if you tell that, okay, the climate change is actually happening, and then the citizens somehow get angry and start to think that, okay, this expert is telling a lie because this expert is involved in big conspiracy or something like that, okay? Then, if you're an expert in climate change, I think you hesitate to tell citizens that climate change is happening. So as such, when citizens have some conspiracy thinking, then experts may ponder to what citizens want to believe in. So as such, the quality of information environment could be impacted, could be determined by, could be influenced by the average level of conspiracy thinking in the society. Okay, so this is the first path. But this is not the end of the story because as the literature in the political science says, conspiracy thinking is formed through some social interactions, like a political socialization and so on. So then it is very natural to assume that the current information environment in turn affect whether the next or young generations will have a conspiracy thinking, right? So as such, there could be some dynamic interaction between the average level of conspiracy thinking and the quality of information environment. So this is the basic idea of our study. And to describe this kind of a dynamic environment interaction, so first of all, we're going to construct a static chip-top communication model from expert to citizens. So here, experts have some reputation concerns, and citizens with conspiracy thinking biasly update beliefs in response to expert message. So this is the first, kind of path. Okay. And then we extend this to a dynamic model with a simple evolutionary dynamics. And in this evolutionary dynamics, the fraction of citizens with conspiracy thinking in the next period is determined by whether having conspiracy thinking is the larger payoff in the current period. Okay, so we're going to consider kind of a replicator dynamic. So, kind of evolutionary dynamics satisfying a payoff monotonicity. Okay, by doing so, we're going to consider dynamic interaction. And then we, show the two results. Okay, so first of all, apparently the accuracy of information expert have is really important in information transmission. And I think people tend to think that, like, so for example, the accumulation of scientific knowledge mitigate the spread of conspiracy theories and so on. So the first of all, we're gonna ask, so whether the accuracy of the improvement of the accuracy of information experts have mitigate the spread of the conspiracy thinking or not. And we show that higher accuracy may paradoxically foster the prevalence of conspiracy thinking in the long run. Okay, so this is the first set of the results. And also the second result may be a bit, not maybe so new, but the initial historical condition may have a long-lasting effect because we may have some multiple stable steady state. And one important thing is that this multiple stable steady state exists only when the accuracy of information experts have is not too high. Okay, so again, the accuracy of information experts have plays a role in determining whether history matters or not. Okay, so that's the second set of the result. So we're going to show this from now. Okay, this is the end of the introduction. So if there are any questions. Okay. Okay, then let me start with the static model. Okay, the static model is nothing related to evolutionary dynamics, but it's just a communication model. Okay, so there is a state of the word omega. This is a binary 0 or 1. Okay, And so, for example, in the case of climate change, this represents whether climate change exists or not or something. Okay. And the probability that the omega is equal to 0 is p. Okay, this is a prior probability. And there are a continuum of seasons, but they do not know what is omega. Okay. And here there is a single expert. Okay. And this expert receives some private signal about this state of the world omega. So this is a signal S. This is again binary. So for example, S represents the scientific information about whether climate change is happening or not. Okay. So the precision of the signal is represented by alpha. So previously I said in this slide, I said that the accuracy of information experts have play a role, right? And this accuracy of information held by expert is represented by alpha. So this alpha plays a role in the foreign analysis. So please remember this parameter value. Okay. And after receiving this signal, the expert send message either 1 or 0. So simply message 1 means that okay, I get the signal 1. Message 0 means that I get signal 1. Signal 0, sorry. Okay. And after observing this message, each citizen chooses a private action, AI. Okay, so and this is a 0 to 1. So this is not a binary. So this is a continuum action space. Okay, so this is just a description of the model. And here we're gonna incorporate the conspiracy thinking into this type of model. And you know, so before moving on to the specific setting, so let me explain that what is the benefit of having a conspiracy thinking. So this is a kind of where it's discussed by the literature in political science and social psychology. So suppose that, okay, you face some factual information that contradict with what you want to believe. Okay, so for example, suppose that you want to believe that climate change is not happening, but scientists say that climate change is happening. Okay? If you have a conspiracy thinking, and then you can start to think that, okay, the scientists say that climate change is happening, but this is not because climate change is actually happening, but because this expert is involved in a big conspiracy and terrorize, right? By doing so, you can attribute this factual information to the conspiracy, and you can continue to believe what you want to believe. Right? You can continue to believe that climate change is not happening. So as such, conspiracy thinking works as a tool to conduct a motivated reasoning. Okay, so this is a kind of a psychological benefit of conspiracy thinking, and we're gonna describe this kind of a stuff in the following analysis. So we're going to consider this kind of a payoff for seasons. Okay. So first of all, this is a season's payoff. And so let's focus on this term first. Okay. So here omega is a state. And so this payoff represents your incentive to match your action with the state of the world. So this is a kind of a very basic accuracy motivation. Okay. But there is another term this is called a goal-oriented motivation. So let's denote pi tilde over m. This is a season i's posterior subjective probability that omega is equal to 0. Okay, so this payoff says that the seasons want to believe that state is equal to 0. Okay, and as your belief diverge from this one, then you get some psychological loss. Okay, so this is a goal-oriented motivation, and the weight for this goal-oriented motivation is denoted by theta. Okay, so this is a season's payoff. So both accuracy motivation and some psychological, let's say, motivation for motivated reasoning are incorporated in season's payoff. Okay. Good. And seasons are divided into either two types, type N and type C. type N is just a very rational guy. They have no conspiracy thinking, so they just update belief in a Bayesian way. That's all. The the interesting point is this type C. This is citizens with conspiracy thinking. Okay, and they have a conspiracy thinking in the sense that they have two types of misspecifications about the model, or I mean that about the world. Okay, so first of all, they think that the sender is the bot type with probability Q. I will show this later, but I will introduce what the bot type means. But that the truth is that we're gonna assume that the truth is that the sender is a good type. The sender is a good type. This is the truth. Okay? But nonetheless, they misunderstand that the sender is a bad type with probability Q. I mean that the sender is involved in the conspiracy with probability Q. Okay? And this is the first misspecification, and I think this is very natural if we consider conspiracy thinking. Right? By definition, we need to consider the belief that that the expert might be involved in conspiracy. The second type of misspecification want to capture the fact that people with conspiracy thinking tend to think that experts are powerful, very powerful guys. Okay. So to capture this, we're gonna assume that the type C citizens misunderstand that the accuracy of information the expert has is perfect. Okay, the expert signal is not perfect at all in the reality, but they misunderstand that this signal is perfect. Okay, and actually both types of misperceptions play a role in the following analysis. And given these two types of misspecification of the model, they update the belief in a Bayesian way. Okay? But because of these misspecifications, their updated belief diverge from the rational one. Okay, so that's the point. Okay, so here that the model misspecification, I mean that incorrect worldview enables the type C citizen to conduct a motivated reasoning. All right, so let me explain what bot type means. Okay, so after observing signal, as I said, the expert sent a chip talk message N. Okay, and we're gonna assume that the reality is that the expert is always a good guy, type G. Okay, this type G citizens basically try to maximize their reputation. Okay, so Ri of M is the subjective probability of the expert being the good guy for citizen I, and because there are continuum of citizens, we just integrate over them. Okay, so this is an average reputation. This is average reputation. And but also because expert, I mean that the expert and has some professional integrity and so on. And so if they tell a lie, it incurs some lying cost, psychological lying cost. This psychological lying cost is given by kappa here. Okay, so this is a lying cost. And this lying cost, of course, could differ across experts. Some experts are very professional and they have high lying costs, but some professional just try to pander to the public opinion and so on. So kappa follows a uniform distribution between 0 and 1. Okay. Although the truth is that every expert is type C, but as I said, that type C citizens, I mean that the citizens with conspiracy think that, okay, but the sender may be the bad type. The bad type is just involved in conspiracy, so always send message 1. Okay? So remember that citizens want to believe that the state is equal to 0. So they want to believe so. Okay? So S is equal to 1 actually contradict with what they want to believe. Okay? So that the people with conspiracy thinking think that the bad guys always send a message 1 and not message 0. Okay? Like that the crime always send a message that climate change is happening. Something like that. Okay? So that's the kind of a model. Okay, so that's the all about the static model. And based on this static model, we characterize the equilibrium, and the equilibrium is basically, simple. In the equilibrium, mean that the perfect Bayesian equilibrium, or variant of the perfect Bayesian equilibrium, the expert. So first of all, suppose that you receive a signal zero. Okay, this signal zero is consistent with what citizens want to believe. Okay, and bad guy always send message one. So if as long as you send a message there, your reputation is not undermined at all, right? So then if you receive the signal zero, and then why not send message zero? So you just send message zero. Okay, it's okay. But what happens if you receive the signal one? There is a trade-off, right? If you truthfully report the message one, and then your reputation will be undermined because the type C citizen start to think that, okay, this expert may be involved in conspiracy and maybe the bad type who always send message one. Okay? So your reputation goes down. But of course, telling a lie incurs some psychological lying cost cover. Okay? So you tell the truth if and only if your lying cost exceeds a threshold value. And this threshold is kappa style. Okay? And this is endogenously determined in the equilibrium. But what is important here is that this capacitor is decreasing in n, and n is the number of citizens without conspiracy thinking. Okay? So as the number of citizens without conspiracy thinking increases, experts are more likely to tell the truth. And I think this is quite intuitive because, you know, type N citizens, rational guys, know that the expert is a good guy. So independently of your, message, your reputation among type N citizens will be never undermined. Okay. So as long as a lot of citizens have no conspiracy theories, you do not have to care about the reputation concern. You can just tell the truth. Even so, if so, your reputation will not be undermined at all. Okay. So we get this result, and actually this is a numerical example. So this is n is a number of type n citizens, rational citizens. It's x-axis and the vertical axis kappa. So for example, in this parameter value, this you know this purple dotted line is a kappa style. Okay. So if your kappa is higher than this, and then you tell the truth. But otherwise, if you send a message one, you pander to the public opinion and you send message. Okay, so this is what we get here. Okay, and another important thing is that if n is sufficiently, so if n is equal to 1, I mean that everyone is a rational citizen, and then you have no incentive to tell a lie, so everyone tells the truth. Okay, but if everyone has conspiracy thinking in the another extreme case, then every expert tells a lie. Okay, so there is a very important property for the following analysis. Okay. So that's almost all about the equilibrium, but let me just briefly examine how citizens behave given the message. Okay, and what we get is that the type C citizens more strongly believe that omega is equal to zero when observing message zero. So we have an overreaction to favorable news. And also type C citizens more strongly believe that omega is equal to zero even when observing message one. So we also obtain underreaction to unfavorable news. Okay. So here A and so for example this one A and M, this is and the action taken by citizen with type N given message N. Okay? And actually this is 1 minus pi tilde of M. Okay? Pi tilde of M is a probability that omega is equal to 0 given M for citizen I. Okay? So basically, they want to, take the action. Well, actually, so this is just the probability that omega is equal to one given message. Okay. So the chosen action correspond to the probability, the posterior probability of omega being equal to one. Okay. So you get this kind of property, and that can be seen in this figure. Okay. So basically, this is AN1. So what happens if you receive the message 1? Okay. If you are rational, you have to take this action. But if you have a conspiracy thinking and then you just take this action. So that means you have an underreaction to unfavorable news. Okay. But on the other hand, if you have Okay, if you observe message 0, this is favorable news for you, right? And then if you are rational and then you still choose this action, but if you are type citizen with conspiracy thinking, you have an overreaction to favorable news. Okay, so this is what we get here. Okay, and this both overreaction and underreaction are important for the following analysis. And by the way, we had two types of misspecification for type C citizens. The first thing is that they believe that the expert may be involved in conspiracy, right? And secondly, they think that the expert is too powerful, meaning that the accuracy of information, the accuracy of expert signal is perfect. Okay. This first misspecification leads to the underreaction to unfavorable news, and this second type of misspecification leads to the overreaction to favorable news. Okay, so in that sense, to get both underreaction and overreaction, we need both types of model misspecifications.
Great question.
Yes,
So those are completely separable then. So if you turn one of those misspecifications off, you lose the effect. So if you just have, say,
yes,
type 2, then you lose the first effect.
yes, exactly,
Okay.
exactly.
And
Yes,
so, okay, in the first case, it looks exactly like the Bayesian guy, then is that the,
yes,
okay.
yes, exactly, exactly.
Thank you.
Thank you so much. Okay, so that's all about a static model. So let's move on to the dynamic model. Okay, so we're going to consider continuous time model, but it can be, of course, discrete, but consider infinite horizon model, and every agent lives for one period and cannot observe the action taken by previous generations. And we're going to assume that there are previously in the static model, we're going to focus on one particular issue, right? But let's assume that there are continuum of issues in each period. I will explain why we have this, why we want to have this later in the next slide. So for now, let's just assume this, okay? And for each, so there are a lot of issues, okay? And for each issue, there is an expert, and this expert send a message. Okay, and given these types of message, each citizen chooses action for each issue J. Okay, and here why we have this? Okay, so we assume that the state of the world is also IID across issues and invariant across time. And one important point is that whether to become type C is applied to all issues. So either you have a conspiracy thinking to all issues, or you have no conspiracy thinking to any issue. Okay. And this is, I think, realistic because, as I said in the introduction, okay, the conspiracy thinking is applied to all issues. So this is a feature of conspiracy thinking, right? If you have one conspiracy thinking, you are likely to have even unrelated conspiracy theories, right? So to capture this, we consider this kind of a setting. And actually, considering this kind of a setting has a very huge benefit for us. The reason is that if we just have one single issue, okay, and then your payoff is very random. in that, so first of all, the expert type is randomly drawn, and expert signal is randomly drawn, and of course, the state of the world is randomly drawn, right? So everything is random. There are a lot of randomness. Okay, so it makes a payoff structure or random, create a randomness about payoff structure. That stuff is not may not be so bad, but it at least complicate the analysis. So for now, just for simple, not for simplicity, we're gonna consider kind of a deterministic process. So for this, we're gonna assume actually a continuum of issues. Then everything average out, right? So the type N is payoff impurity becomes deterministic, and type C's payoff impurity is also deterministic. So we can consider, we can characterize the dynamics in a very simple way. Okay. And also we believe that this is realistic because in reality there are a lot of issues about conspiracy theories, not only about climate change, but also, COVID-19 or economic related conspiracy theories, election frauds, and so on and so on. Okay. And what kind of a dynamics we're going to consider? So we're going to consider very simple dynamics that satisfies a payoff monotonicity. So that means the fraction of seasons without conspiracy thinking increases if and only if the payoff when becoming type N is larger than the payoff becoming type C. Okay. And so this includes, of course, the replicator dynamics, and also, it includes best response dynamics, and also it can be micro-founded based on the cultural transmission. So that's what we're going to consider in this study. Okay, that's all about the dynamic model. And so also the setting of the dynamic model. And so what is the key trade-off here? So, by the way, okay, so let me say that for this payoff, we consider not only about accuracy-oriented motivation, but also we take into account the goal-oriented motivation. Okay? This is because the psychological payoff, the goal-oriented motivation, is just a subjective psychological payoff and not the material payoff, but it affects the mental health of each citizen, right? So, for example, that if you want to believe that omega is equal to 0, and by just believing so, it makes you happy and so on, right? And it improves your mental health, and that will affect your evolutionary fitness, something. So we take into account both motivation in calculating this utility. I think this is a bit different from the standard, that evolution dynamics model, but that's what we're going to consider in this study. Okay.
Okay, but
And
then, okay, can I ask a
yes,
question here?
sure.
But then you have chosen that one of the states is the one that is motivating, right? It's
Yes.
only one of them, which is exogenous.
Yes.
In a sense, what I'm trying to say is that if this enters my if this enters my fitness, why should this particular belief, if it's not materially driven? Can you elaborate a bit on this?
Oh, I see. Yeah, yes. So this is just a psychological belief. So first of all, and I agree that this is just one particular type of a psychological belief. So there are a lot of determinants of psychological payoff. But as I said, here we have a lot of issues. We implicitly assume there are a lot of issues, right? If you have a conspiracy thinking, for many issues, you can continue to believe what you want to believe, and I think it severely affect your mental health or your happiness level and so on. So for example, I think one particular thing is about your belief about your ability. Okay. So for example, that typically, many empirical papers shows that the people tend to conduct a motivated reasoning about own ability level. Okay. So for example, that if you can continue to believe you have a higher ability and so on, and then I think it makes you happy and your mental health is substantially improved, even if it is not true. Okay, so we're gonna try to capture that kind of aspect, yes. Yes.
So are you
Yeah.
saying that the blue part is the material utility and the red part is the psychological?
Psychological utility or something. Yes.
Okay.
Yes. And then there is a trade-off here, right? Becoming type N is of course better in terms of the material payoff because you can formulate the accurate belief. But at the same time, but on the other hand, becoming type C is better in terms of this psychological, I mean, the goal-oriented motivation, because you can continue to believe what you want to believe. Okay, so there is a trade-off here. And the important point is that n is a fraction of citizens without conspiracy thinking, right? And this affects the quality of information environment, the impurity, as we see in the previous slide, right? And then this affects this trade-off. So for example, let's suppose that a lot of citizens have conspiracy thinking. So almost every expert tell a lie. Then the quality of information from expert is really low, right? So then even if you become type N and you try to form accurate belief, if the information transmission from expert is not informative at all, and then you cannot formulate the accurate belief. So then the benefit of becoming type N in terms of material path is almost negligible at all, right? So as such, the current fraction of citizens without conspiracy thinking affect this trade-off through the quality of information environment. So this is the basic idea of our study. Okay. And then we get the several results. So first of all, let's start about a very simple stuff. So we're going to consider two polar case. Okay. N is equal 1 and n is equal to 0 and check whether these are locally stable or not. So I think this result itself is very intuitive, but n is equal to 1 is locally stable if and only if the level of goal-oriented motivation falls below a threshold, say the 1, and n is equal to 0 is also locally stable if and only if, say, to exceed a threshold, say the 0. Okay, I think this itself is nothing, interesting, and it's very straightforward. But anyway, we can get this kind of a result. And let me just add one note remark for the following analysis. That is about how these thresholds are determined. Okay. So in general, given the fraction of citizens without conspiracy thinking, becoming type N is better if and only if theta is smaller than this value, this large theta of n, and this large theta of n is given by this complicated formula. But here, the denominator, this is represent the kind of the advantage of type C in terms of goal-oriented motivation. Okay. And this one, the numerator, represent advantage of type N in terms of accuracy motivation. Okay. So they did, the trade-off is actually captured by these both numerator and denominator. Okay. And theta 1 is just theta, large theta of 1. And theta 0 is just the limit of theta n when n goes to 0. Okay, why we consider the limit case? This is because when n is equal to 0, okay, when n is equal to 0, that means every citizen has conspiracy thinking, and then actually no one tells the truth. Everyone tells a lie. Given that everyone tells a lie, information is not informative at all, right? And everyone send a message zero, right? Everyone send message, always send message zero. So first of all, this term becomes 0, okay? And this is equal to 1. But because message 0 is totally uninformative, this and this are exactly the same. So the denominator is just 0, okay, when n is equal to 0. Okay, so that's why we take the limit. But anyway, so this is the proposition, the second proposition. Okay, given this proposition, so let's see how alpha is the accuracy of the signal of expert, affect the prevalence of conspiracy thinking. So first of all, we get these results. So first of all, theta 0 is increasing in alpha. So let's see this numerical example. So first of all, theta 0 is increasing in alpha. Okay. And in this red region, n is equal to 0 is stable. Okay, so n is equal to 0 is less likely to be locally stable as alpha goes up. So in that sense, the more knowledgeable expert are, the less likely the full prevalence of conspiracy thinking is to be locally stable, right? So this is intuitive, I think. But if we consider the opposite case, the same intuition no longer holds. That means when alpha goes up, actually theta 1 is initially decreasing. Okay. In this blue region, n is equal to 1 is stable. Okay. So that means n is equal to 1 is could be less likely to be stable as alpha goes up. So this means that the more knowledgeable experts are, sometimes the more likely conspiracy thinking is to be contagious, right? So for example, if initial theta is, let's say, here, okay, and alpha is here, 0.6, if then n is equal to 1 is locally stable. But if alpha goes to 0.7 and then n is equal to 1 is no longer locally stable. So even if initial n is around n is equal to 1 and diverges from n is equal to 1, right? So this is kind of an unintuitive result we all get. And this means that the kind of accumulation of scientific knowledge could backfire, right? Does not necessarily prevent the prevalence of conspiracy thinking. Okay, so that is our first result, and the intuition is a bit complicated, but I think to understand that that this kind of thing could arise is not so difficult. So first of all, an increase in alpha has a following four effects. So first, it increases the accuracy payoff when becoming type N because the information from expert is more accurate, right? Second, it has an ambiguous effect on the goal-oriented motivation when becoming type N. So this is ambiguous because if you receive some message, this is what you want to believe, right? Because that the information becomes more accurate, so you react to this information more, and this improves your goal-oriented motivation. But if you receive some message 1, you don't want to react to this message, but an increase in alpha makes you react more to this unfavorable news. So this is a bad thing. So this is both a positive effect and negative effect. So the total effect is ambiguous. Third, it increases even the accuracy payoff when becoming type C, right? Because if you misunderstand that the expert is too powerful and the expert information is perfect, this is wrong. But when alpha becomes closer to 1, the cost of this misspecification becomes lower, right? Is mitigated. So that is the third effect. And lastly, it has no effect on the goal-oriented motivation when becoming type C. Okay. So the important thing is A, B, and C. And the important thing is that sometimes A is dominated by C. Okay. So an increase in alpha can make a type C more attractive because it increases the accuracy, it improves the accuracy payoff when becoming type C. So that is a kind of an intuition. And I think you might have a kind of a question about why this kind of a effect doesn't arise when, say, n is equal to 0, and why it could arise when n is equal to 1. But it's a bit complicated. But I can answer to that question if you have a question later. Okay, but anyway, so that is the first result. And yes, and then, so this is a same numeric example, okay? So here you can see that in this region, both n is equal to 1 and n is equal to 0 are locally stable, right? And actually, we can get this kind of a result in a general environment. So when alpha is sufficiently small, theta 1 is greater than theta 0. So that means both n is equal to 1 and n is equal to 1 are locally stable for intermediate value of theta. Okay. So you can see this from this numeric example. So here actually, alpha is 0.7 and theta is 0.2. And here both n is equal to 1 and n is equal to 0 are locally stable. And here, this is a un minus uc, and this is a 0, right? So if the initial n exceed this n bar, 0.669, let's say here, and then becoming type n is better than becoming type C, right? So n goes up. Still, un is larger than uc, so n goes up, and n goes to 1, right? But on the other hand, if initial n is lower than n bar, and then n goes down, and then combines to 0, right? So depending on the initial value of n goes to 1 or goes to 0, and there's no other locally stable state. So we can get this kind of a result, and this means that whether conspiracy thinking could spread depend on the initial proportion of people with such thinking. And so that means the even slight difference in the initial state can lead to significant variation in the long-run spread of conspiracy thinking and the quality of information environment. Okay, so I want to emphasize that this is a bit different from the standard, that the kind of mechanism of complementarity. Okay. The reason is that when n is equal to 0, as I said, no information is transmitted, right? So actually becoming type C and becoming type N are totally indifferent. Both yield the same utility. So for any parameter value, when n is equal to 0, un is equal to uc. Okay? So if there is just a complementarity and then n is equal to 0 is never locally stable, right? And just n is equal to 1 is stable. So dynamic, that the global complementarity does not never create, multiple steady state. To create a multiple locally stable state, initially we need have some strategic substitute, and then we get the complementarity, and then we have a multiple stable state. And I think this is a bit different from a standard logic of a multiple stable state, but this is what we get here. Okay, and then, so here is an implication of this results of multiple stable states. So as I said at the introduction, several studies have argued that the conservatives are more prone to conspiracy thinking than liberals. But recent evidence shows that the relationship is not universal across countries. And our results indicate that observed such cross-group disparities in conspiracy thinking may not reflect intrinsic differences in ideology or psychology. It might be just because of some distinct historical initial condition, and that is of course vary across countries. So it is not surprising that in some countries liberals are more prone to conspiracy think, but in other countries the conservatives are more prone to conspiracy thinking. So we should look at the historical conditions. So that's our argument. Okay. But of course, it is not the case that multiple stable states always exist. When alpha is close to 1 and then theta 0 is greater than theta 1, then for intermediate value of goal-oriented motivation, neither n is equal to 1 nor n is equal to 0 is locally stable. So in this figure, in this region, right? Neither n is equal to 1 nor n is equal to 0 is locally stable. So instead we have a interior stable state here. So independently of n, initial n, things that converge to this point, 0.63 or something. Okay. But the point is that whether multiple stable state exists or not depend on the alpha, the accuracy of the signal received by the expert. So again, this alpha plays a role. Okay. So I think that's almost all I have to say, but let me just say one extension. It's about effect of fact check. So recently, in response to the spreads of misinformation, disinformation, the conspiracy theories, that a lot of attempts are made by, social media platform or third parties, and I think a fact check is one well-known example, right? So let's see how fact check affect the prevalence of conspiracy thinking. Okay, so let's suppose that the fact checker observes a signal received by the expert and checks whether their message is consistent with this signal. Okay, she just confirms or denies a message sent by the expert. It's binary. But let's suppose that for simplicity, assume that the fact checker always behaves truthfully. So in that sense, fact checking works objectively. Okay, but let's assume that the type C citizens believe that with some probability the fact checker is also a bad type who always denies message here. Okay, so this is I think realistic because in reality, people with conspiracy thinking do not trust not only about the expert but also about the fact checkers, right? So type C citizens subjectively distrust the fact check. Okay. And then the question is, does its presence prevent the prevalence of conspiracy thinking or backfire? And what we're going to show from now on is that even if pi is close to 1, that means the type C citizen think that, okay, the fact checker is almost always involved in conspiracy. Even if in such kind of a pessimistic environment, fact checking can play a role in preventing the spread of conspiracy thinking, as long as fact checkers objectively behave truthfully. So here is the result. So theta 1 doesn't change due to the fact check, but theta 0 goes up. Okay, so here, previously theta 0 takes the form something like this. Okay, or not this. I think this is true. This is long, but like this. Oh, not this. I think like this. Yes, like this. This is a kind of previous theta 0. But because of the fact checking, theta 0 goes up toward this. Okay, and this is a large change. And so, for example, for this type value of theta, n is equal to 0. It's not stable without fact checking, but now it is locally stable. Okay. And the point is that this happens even if pi goes to 1. So that means even if the type system totally do not believe the fact checker. Okay. That is what we get here. Okay. So let me summarize. So the research question was, what is the cause of cross-country or cross-group differences in conspiracy thinking? And we show that the accuracy of information experts have matters, but higher accuracy may paradoxically foster the prevalence of conspiracy thinking, the backfire effect. And initial historical condition may have a long-lasting effect when the accuracy of information held by experts is not so high. And we also explore the effect of fact-checking. Okay. And there are several related literature, but I think this is a good time to stop. So yes.
Okay,
So let me stop here. Yeah.
great. Thank you very much. Stop recording now, and then we'll take some questions.